Okay, so in today's video, we're looking at canceling or reducing fractions. Now, it must be said that not every fraction can be canceled or reduced. How do you know? Well, it goes back to what we did last term in terms of HCF, or highest common factors. So here we have this fraction 12 over 15. And we would like to see if we can reduce 12 over 15 into its lowest terms. A way to do that is to simply write out the factors for both 12 and 15, find what is common, find the highest common factor, and then divide both 12 and 15 by that number. And our answer will be our fraction in its lowest term. Let me show you how it works. So we have 12 over 15. Let's find the factors for both of them. So the factors for 12 and the factors for 15. Alright, now factors for 12. Now you guys should know how to find factors. But just to give you so the factors for 12 are 1, 2, 3, 4, 6, and 12. And the factors for 15 are 1, 3, and 5, and 15. Remember, factors are numbers that can divide a specific number without getting any remainders. So for our factors of 12, all of these numbers can divide 12 and not get a remainder. Similarly, for 15, 1, 3, 5, and 15 can divide 15 without giving us any remainders. Okay? Alright, so we have our factors for 12 and our factors for 15. We now look and see which factors are, well, common. So we have a 1 here and a 1 here. We have a 3 and a 3, and it seems like that's it. Okay? So our common factors are 1 and 3. So our HCF, or the highest common factor for 12 and 15, well, it's 3. Once we know what our HCF is, our highest common factor, then we simply divide our fraction by that highest common factor. So we're going to divide our numerator by 3. And we're also going to divide our denominator by 3. So we're dividing the fraction, both top and bottom, numerator and denominator, by our HCF, which is 3. Let's see what we get. 12 divided by 3 will give us 4. And 15 divided by 3 will give us 5. So therefore, this fraction, 4 over 5, is 12 over 15 in its lowest terms. Let's try another one. 6 over 8. Okay, so again, we start off by writing our factors for both numerator and denominator. So we have 6. And those factors are 1, 2, 3, and 6. And we have 8. Those factors are 1, 2, 4, and 8. Now, let's see what's common between 6 and 8. You see that 1 is here. And as you can tell from last term when we looked at factors, 1 is common in everybody. So in all of these examples we have here, 1 should be the first number that is common in the list. So we have 1, 2 is also in here, and nobody else. Yeah, nobody else is common. Okay, so 1 and 2 are the common factors, and therefore the highest common factor would be 2. So our HCF is 2. And now that we know what our HCF is, we divide both top and bottom by our HCF 2. And this will result in giving us our lowest 6 over 8 in its lowest terms, or canceling 6 over 8. So 6 divided by 2 is 3, and 8 divided by 2 is 4. So 6 over 8 in its lowest terms is 3/4 or 3/4. Again, we can also say that 6/8 is 3/4 when it's cancelled or when it's reduced. Let's look at another example. 10 over 20. Okay? Bigger numbers. Let's go. So we first list the factors of 10 and the factors of 20. Factors of 10 are 1, 2, 5, and 10. Okay? The factors of 20 are 1, 2, 4, 5, 10, 20. Let's see what's common. So we have 1, like I said before, it's going to be common. To have 2 again, nice. I see a 5 here, and a 10 is also here as well. So now we have a good set of common factors in this list. Let's see which one is the highest. I believe it would be 10. So 10 is our HCF. Alright. So now that we know what our HCF is, we simply divide our fraction, both top and bottom, by our HCF. So 10 is going to be divided by 10, and 20 is going to be divided by 10. This is what we get. 10 divided by 10, that should give us, well, 10 into 10, any number divided by itself is 1. And 20 divided by 10, that should be, well, 20 is twice the size of 10, so 2. Yeah. So therefore, we have expressed 10 over 20. We've canceled it down to its lowest terms, which is 1 over 2, or a half. And this makes complete sense, because when we had 10 over 20, 10 was half of 20. So the fraction is a half. Yeah. Let's look at another one. 5 over 9. Let's start off by listing, like before, the factors of both the numerator and the denominator. So the factors of 5, I believe 5 is a prime number. So prime numbers only have 2 factors, 1 and itself. Yeah, that's correct. And 9 is not a prime number, so it should have more than 2 factors. So we know it has 1, and we know it has a 9, obviously. We're missing 1. 3. Yeah, 3 is a number. So we have our factors for 5, we have our factors for 9. Let's see what is common. So we have 1 is here, 1 is here, and oh, wait, hold on. There's nothing else that's common. So our HCF is 1. Now, how does that play into this? Well, we can divide everything by the HCF, which is 1. So 5 divided by 1 and 9 divided by 1. But if you remember, when you divide something by 1, then it stays the same. So 5 divided by 1 is 5, 9 divided by 1 is 9. And this is interesting because 5 over 9, when we write it in its lowest terms, it's still 5 over 9. And the reason for that is that 5 over 9 was already in its lowest terms. So whenever you have a fraction where the only common factor is 1, you don't have to do anything else. It's already in its lowest term, 5 over 9. All right? Okay, so I want you to try these 4 items. You have to reduce them to their lowest terms or cancel them as far as you can go. Okay, so you can pause the video and do that. Alright, so I trust that you've did the problems, you wrote down the factors, found the HCF, divided, and got your answer. Let's see how it works. So our first one, 2 over 6, the HCF is 2. So we divide both the numerator and the denominator by 2, and you're going to get 1/3. For the second one, the HCF is 1. So this remains the same. When you divide 3 and 7 by 1, you get back 3 over 7. For number 3, your HCF should have been 2. So you divide both 14 and 16 by 2, and you get 7 over 8. And for number 4, your HCF should be 6. So you divide both 12 and 18 by 6, and you should have gotten over 3.